Greetings and welcome. This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In today's session, we will be learning about the friction and loss of friction and the important terms that are involved in the friction and types of friction. Whenever the surfaces of two bodies are in contact, there is a limited amount of resistance to sliding between them. This resistance is called as friction or frictional force. For example, let us consider two bodies that are a table and a book. Let us say a book is placed and this is a table. Right. So this book and table are in contact here. The lower surface of book and upper surface of table are in contact with each other. So in this case, what happens? The surfaces which are in contact with each other, if we try to move the bodies, let us say it may be table or the book, then the restriction, we need to apply some force for the movement of the book on the table. So that restriction which is happening and which is making us to apply some force onto the book for the movement is termed as the friction. Friction is a phenomenon where it is required in some cases and it is not required in some cases. So it plays a key role in very important aspects like the engine components. In engine components, where the parts of the engine moves vigorously when the engine is in running condition, the mating parts, that means one part which is combined with the other part, they need lesser friction so that the engine parts will not damage. The friction must be less. So we will be using some lubricants in the engine parts or the IC engines. That lubricant is called as the coolant of the engine. Then the requirement of the friction where we are walking on any road or any floor, right? The friction should be prevailed there so that we will not slip on. And it becomes necessary in that condition where friction is very important. So for understanding this clearly, let us consider a table here and a box is placed on the table. And a force of P is being applied onto the box towards right side. And this is your friction which acts at the contact point of the lower surface of the box and upper surface of the table. And that friction will also restricts the motion. That's why we will be saying that the friction will act in the opposite direction to the movement of the object. So as the box moves towards right side because of the application of force P, the frictional force will always act in the opposite direction of the movement of the box. And because of the friction that is being applied here, the weight of the box gives us the term called as normal reaction, where the normal reaction always acts towards the object and at the point of contact of the surface. And this is called as the resultant reaction, where the reaction between the frictional force and normal reaction becomes the resultant reaction. And this phi, the inclination of this resultant reaction, is called as the friction angle. So best example why this restriction happens is explained here. You can observe a box placed on the table and we are taking a small area here and it is being enlarged for the understanding. Here you can observe, we know that all the surfaces cannot be perfectly smooth. Some unevenness will be present on the surfaces. So the lower portion, lower surface of the box and the upper surface of the table will have some unevenness as shown here. And the unevenness will interlock themselves. See, here the interlocking will happen of the unevenness. So when you try to move the object, then what will you need to do? You need to break these interlocks. You need to break these interlocks for the object to move. So for breaking these interlocks of the uneven surfaces needs some force to be applied for the object to move. So in the previous module which you have seen, the equilibrium condition or the resultant calculation, all these things, there we have not considered any friction because we are considering those are the smooth objects. Here in this module, the frictional force comes into picture where, as we are saying, friction is the phenomenon which is considered as the force, right? So we have to overcome the frictional force. Now, a brief understanding of how do the things move. A ball rolls on the floor, then it, after traveling to some distance, it will stop. And the rollers and the sliders, roller skating and the sliders, they will be moving on the surface. And we will be applying some force for holding the water bottle. And there will be some caution given when the floor is wet so that the friction will be very, very less on the floor. So, once the object is moving by in contact with the other object, friction will be prevailing. So, that friction will also acts always in the opposite direction to the movement of the object. Here you can see the sliders and the rolling friction and the object when we hold it, the friction is, the bottle tends to move downwards, we are applying some force so that the friction will be applied in the upward direction. Then coming to the floor, that friction will be having lesser so that we will be slipping. Then always the friction will act opposite direction to the movement of the object. There will be low friction and high friction depending on the weight of the objects or the bodies in contact and the surfaces in which the objects are in contact with each other. So the low friction will be seen on the wet floor. Now coming to the types of friction. There are 4 types of friction that are generally seen. One is static friction, sliding friction, rolling friction, and fluid friction. So the static friction and sliding friction are the examples now we can see as holding the water bottle is the static friction and sliding friction is the friction that is prevailing when the object is moving, like we can see it in the sliding of the roller skates. And the rolling friction, the ball which is rolling on the floor. And the fluid friction is the friction which comes into picture when the fluids are obstructing the movement of any object. Now let us see the static and kinetic friction. Static and dynamic friction. Static friction is the case where we can take the example of a stationary sofa here and a force is being applied. How much force will make the object to move here? We should be applying the force so that the contact links, the unevenness should be breaking. And that contact links unevenness will be dependent on the weight of the object. So this is the static friction. Even though you are applying the force, here when you have observed, even though you have applied the force, the object is not moving. That represents the force which is applied is not sufficient to overcome the friction. So this friction which is prevailing when the object is not moving is called as the static friction. And this static friction will always be equal to the force which is being applied. So the upper limit of the frictional force which exceeds the movement is called as the limiting friction. So for the movement of this sofa, what should be needed? We should be needed a higher force. We should be applying some higher force so that the sofa gets moved. Right? So for applying that higher force, it results in the movement of the object. The horizontal force which is being applied and the frictional force that is being covering this friction, horizontal force that is being applied, it depends directly on the force which is applied. So here until the frictional force applied, the horizontal force applied, both are equated, that limiting point is called as the static friction. And after that static friction point, the linkages will break and the object will try to move. So after that object starts to move, it is called as the sliding friction or dynamic friction. And the time up to when the object doesn't move, even though the application of the force, that is called as the static friction. And the instant where the movement of the object starts is called as the limiting friction. So this is the breakaway point where once the linkages, the limiting friction is exceeded, the object will try to move. And that object's movement, the application of force is needed very less compared to the static friction, because once the object starts to move, it is the linkages between the surfaces is very lesser to be easily broken. So the application of force after the sliding friction or the dynamic friction starts is lesser than the static friction. So always remember, static friction will be higher and dynamic friction will be lower. These are the examples where static friction, sliding friction and rolling friction, the force, increasing order of the force that is needed. For static friction, we have just now discussed that the application of force will be always higher and compared to the kinetic friction, that is sliding friction. And rolling friction, because of the rolling, the contact point is very less, only a point contact will be there. The rolling friction needs very lesser force for the object's movement. Coming to fluid friction, we can say the air and water are considered as the fluids: solid, gaseous and liquid. So solid will have the dry friction, which is called as the contact point solid friction. Then air and water will have the fluid friction. So fluids are the liquids and gases. Liquids and gases are considered as the fluids. Here in the example, you can observe the aeroplane, the plane which is flying in air. Air is the resistance that the plane has to overcome. As the resistance increases, the plane has to apply more force for the movement of the plane. Also in water, when the fluid, the water, liquid, it applies some resistance to the movement. So we have to overcome the resistance and we will be needing an engine for the movement of the object, or we need to apply some force for the object to move. Now coming to the laws of solid friction. Frictional force always opposes the motion. This is the very first law which we need to understand. Frictional force always opposes the motion of the object. Then frictional force is independent of the area in contact and depends upon the nature of surface and its roughness. Third law is frictional force is proportional to the normal reaction between the surfaces. This can be represented as F is proportional to N. When we need to remove this proportionality constant, we can apply the coefficient of friction as the constant, which can be given as F is equal to mu N, where mu is called as the coefficient of friction. And the coefficient of friction mu can be obtained in any solvation purpose of the problems as mu is equal to friction by normal reaction. Here the equation which we have obtained is from the friction is directly proportional to the normal reaction between the surfaces. Then next law is the statical frictional force at any instant is equal to the force applied to the body. Then for low speeds, the kinetic frictional force is independent of the speed but increases slightly with increase in the speed. These are the laws of solid friction. Coming to the coefficient of friction and angle of friction, these are the terms which are utilized in the friction criteria. The coefficient of friction is defined as the ratio of limiting force of friction to the normal reaction between the two bodies in contact is called coefficient of friction. That can be given as mu is equal to F by N. This is important criteria. And the angle of friction, the angle between the resultant reaction and normal reaction that we have discussed earlier. Resultant reaction and normal reaction at limiting condition is called as the angle of friction, and it is denoted by phi. You do remember this angle of friction. It may be asked in many problems for identifying the angle of friction. So the angle between the resultant reaction and the normal reaction at limiting condition is called as the angle of friction. For understanding this, let us see the force which is applied, frictional force. towards left side, and the normal reaction that is towards the object, and the resultant reaction which is the reaction of F and N both combined, and the inclination between this normal reaction and the resultant reaction is called as the angle of friction. So if we apply the triangle from these three forces, we can observe the angle of friction like this. And tan phi can be obtained from this right angle triangle as F by N, that is equal to mu. So directly the relation can be obtained as tan phi is equal to mu. So there is a relation between angle of friction and the coefficient of friction. So tan phi is equal to mu is the relation. Now coming to angle of repose, it is the angle theta where when the inclined surface is lifted to that angle, the body tends to slide down without any external force. Even though we are not applying any force, if we just lift the surface on which the object is placed, the object starts to slide. So that is the angle theta where the inclination point will be starting the movement of the object that is being placed on the surface. So this is the inclined surface which we consider, which is inclined at some angle to the horizontal, and an object is placed here. And the weight of the object will always act vertically downwards. When we increase this inclination, then what happens? The object starts to move downwards because of its own weight, right? So this theta angle is called as the angle of repose. And now cone of friction. It is defined as an imaginary cone generated by revolving the resultant reaction about the normal reaction. See, as we have considered the initial example where the box is placed on the table and a force P is applied, here you can observe the normal reaction and resultant reaction, which is having an inclination of phi. When this resultant reaction is rotated to 360 degrees, this is the normal reaction, and this resultant reaction is rotated to 360 degrees, then what happens? An imaginary cone forms. This imaginary cone is called as the cone of friction. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.